In this video, we're going to show how EnRoute software makes it easy to toolpath a relief that's been created with a file from VectorArt 3D. At this stage, we've already created the relief, and we've created a different movie to show how that's done. If you haven't seen that movie already, you might want to watch that one first to get an idea how to get to this stage. So what we've done is we've created a relief, and the thickness of it is about 0.618 inches. I'm going to bring up my Precision Input Center by hitting F2, uncheck proportional, and maybe make this a 0.48 inch part. This has changed it just in the Z-axis and not in the XY axis. Now I'm going to take my part, and I will change my, before I do anything else, I'm going to come here and change my material size to reflect a 1/2 inch piece of material. .5 inches of material. Alright, now the next step will be to move my material into the plate so I can position it and make sure that I'm going to be cutting this part out in the proper location. I have a button up here with the relief selected. I can go to the Align Reliefs to Plate and choose Move All Reliefs to the bottom of the plate. Because my plate was just a little bit thicker than my material, I have a little bit of extra material here up top to keep from getting any flat spots. I can always move this down a little bit more if I wanted to have a little extra clearance there. Another way I can position the relief in the plate is to use the Precision Input Center and use these diagrams, which are represented by each of the control handles here. I can see that the bottom handles are at -0.5 and the top handles are at -0.02. I can easily input any value here to move the relief around the plate. Now we're going to create the rough toolpath, and to do this we're going to choose between an island fill or a rough fill, and the hatch fill will go back and forth. An island fill will do a contour of the part and maybe be a little bit more efficient. So I'm going to choose island fill. Because I have a relief selected, it automatically prompts me to apply this to the relief. And in EnRoute, the Toolpath engine is the same for the 3D and 2D objects. The next step will be to define an overcut. This will determine how much my bit can go past the edge of the part. In a typical island fill, only the edge of the tool would go to the contour selected, but in a 3D relief toolpath, we want the middle of the tool to go to the edge or beyond. I do this by checking Apply Overcut and specifying a specific amount. I'll go a little bit over half the diameter of the tool. So if I'm going to use a 1/4 inch end mill to do the rough, I'll choose 0.126 for the overcut amount. Now I'll go to my list of available tools, and I'm going to sort these by end mill. I'm going to choose a 1/4 inch end mill, and by double clicking it, it appears up here as the first tool in the strategy. Although I could do my rough and my clean toolpath in one island fill, I'm going to apply them as separate island fills so that I can control these parameters in a different manner. Next, I'll come here and choose Edit, and this allows me to get to the cut definition with a little bit more specific information about this tool. In this case, I'm going to determine the depth of my cut, and if it's a 1/2 inch part, I'm going to put 0.5 inches. I'm going to offset from the surface 0.01 inches, and this will prevent my rough tool from cutting into my relief. If I want to do a 2D step rough, I can check this part, or if I want my rough pass to actually follow the surface, then I can leave it unchecked. In this case, I'll do a normal rough and not a 2D rough pass. Sometimes you might do a combination for thicker parts of a 2D rough and a 3D rough in addition to the normal fine detail pass. Now I can determine how many passes I want this to create depending upon the material. I might choose to do this in 2 passes or 1 pass. And I determine the feeds and speeds. If you're not sure of what feed rates to use, you should check with your tool provider. I'll enter some values here and hit the OK button. Now I'm ready to create the toolpath by hitting OK. I can see that the toolpath has been applied to my object. If I come up here to the perspective view, we can see that it's moving up and down with the surface. Now I'm going to apply the more detailed toolpath. With the relief still selected, I'll go back to the island fill. I'll clear this tool out and I'll choose an 1/8 inch ball nose tool. So we'll come here and choose ball nose. I'll select the 1/8 inch tool and again specify a depth of 0.5 inches. I don't need quite as much of an overlap in this case because the tool diameter is smaller. So I'll move this to 0.08. Next, I'm going to determine the amount of depth, which is 0.5 as we said earlier, and the fill percentage. We're going to use a 90% overlap, which means that we will get pretty good coverage of this area, and that should help to give us a nice detailed surface. Because we've already roughed away the other material, we can leave this at one pass. And again, we would input this feed rate information. When I hit OK, this brings me back to my first screen. I can hit OK to apply the toolpath. Also, if I'm using the same toolpath parameters over and over, I can easily save this and reuse it without having to enter this information in every time. I'll hit the OK button and the more detailed toolpath will be applied. The next step is going to be to create a cutout for this part. Because my relief is based upon a 2D geometry, I'm going to come here and go to the Setup menu and go to Preferences, go to the View Preferences, and turn off the toolpath. That way I can just see the part even though the toolpath is still applied. Because this is based upon a 2D geometry, I can just come up here to my routing offset, which is a type of profile cut, and directly apply the toolpath to this 2D object. I'm going to select an end mill for this. Again, I'll go with a 1/16 inch end mill to get into the tighter areas, and I'll choose my depth. Although I could choose apply to relief here, there's no reason to do this because I really want to treat this as a 2D object. I'm choosing 2 passes here, and because of the amount of material we've already taken, we could probably do this in one toolpath. Here I'll set my feed rates. Because I have a fairly small part here, I also have final pass checked, and this means I'm going to create a little bit of an onion skin. So now I'll choose my final pass feed rate, my plunge rate, and my spindle speed. Again, all of this information could be saved as and easily recalled. I can also choose to do a ramp entry if I'd like to. When I hit OK, the toolpath will be applied. Now I can hit or go to the Setup menu again, go to my View Setup, and turn the toolpaths back on. In this case, I'm just going to take a look at my 1/8 inch end mill, and I can see that it is providing the cutout of the part. I can go to my View Setup menu again, and I can take a look at the 1/8 inch ball nose tool and see that that's my more detailed cut. And I can go to the View Setup and see the 1/4 inch end mill, which is the rough tool. To make sure everything's going to come out okay, we're going to render this. I'll increase my resolution so I can see it a little bit better. Next, I'm going to choose the order. I'm going to order this by tool, and I'm going to do my 1/4 inch rough first, then my ball nose detail cut, and then my cutout pass last. I'll tell the simulator to go to the next tool lift, and the first tool will simulate. Here I can see that a kind of a stepped surface has been created. Next we'll go to the 1/8 ball end mill. If I zoom out a little bit, it'll update where it is in the process. And we can see that the detailed aspects of the surface have been created. This will allow me to determine if the tool I've selected is giving me the amount of detail I'd like. The final toolpath will come and cut the part out from the material. This is an example of how easy it is to toolpath vector art 3D files using EnRoute software.